My name is Chai Sharafi. Here is our presentation video on our work. Automatic Relation-Aware Graph Network Proliferation. Traditional GNS methods adopt a coarse-grained GNN search space, which usually neglects learning relational information. Besides, they use naive differentiable search strategies as the engine, which suffers subnetwork interference and quadratic complexity. In this paper, we propose automatic relation-aware graph network proliferation, short for ARGNP, for efficiently searching GNNs with a relation-guided message passing mechanism. Specifically, first, we devise a novel dual relation-aware GNN search space that comprises both node and relation learning operations. These operations can extract hierarchical node and relational information and provide anisotropic guidance for message passing on a graph. Second, we design a network proliferation search paradigm to progressively determine the GNN architectures by iteratively performing network division and network differentiation. The proposed dual relation-aware GNN search space comprises two kinds of operations: node learning operations and relation mining operations. The node learning operations can implement the anisotropic message aggregation under the guidance of relation features. The relation mining operations can extract relational information hidden in each pair of edge-connected nodes. It realizes the organic combination of node learning and relation mining in message propagation on the graph. For node learning operation, IJ, it can transform the low-level node features, VI, into the high-level node features, VJ, through message passing, in which the relation features, EI, are required to guide the neighbor aggregation. Specifically, for node T and its neighboring node S on the graph, we first calculate the affine transformation gamma and beta to modulate the incoming message of node S. After that, the messages are aggregated by a candidate aggregation function to update the feature of node T. For relation mining operation, IJ, it can extract the new relational information from the edge-connected nodes according to the node features, VI, through relation mining function. Then it is used to supplement the low-level relation features, EI, for obtaining the high-level relation features, EJ. Specifically, the extracted relational information are used to generate a affine transformation for performing feature-wise linear modulation. Different from the traditional methods, we explicitly model the edge features in the GNN search space. As a result, we can directly leverage the global edge features for edge-level prediction tasks instead of concatenating node features. Moreover, we can also construct the global graph representation with the global edge features for embedding more useful information. Next, we propose the network proliferation search paradigm. It can iteratively search for the final GNN architectures by sequentially performing network division and network differentiation. The network division divides each feature vertex into two parts and constructs a series of local supernetworks. The network differentiation aims to differentiate each local supernetwork into a specific subnetwork. Here is the animation to illustrate the whole process. Since the space-time complexity is proportional to the number of the whole operations, we can easily prove that the time complexity with respect to the network size is reduced from square to linear. According to the ablation study on search space, we have two observations. First, mining and leveraging the relational information can significantly improve the GNN's reasoning capability. Second, relation-aware GNN search space can achieve higher performance with fewer parameters. According to the ablation study on search paradigm, we have three observations. First, the cell sharing trick improves the search efficiency, but seriously narrows the original search space and limits the final search GNN's capability. Second, our network proliferation search paradigm can both improve the search effect and search efficiency. Third, our proposed search paradigm works well with different search strategies. Here are four results after searching on the cluster dataset. Thank you for your listening.